Alright, good evening guys. Today we're going to talk about the most basic quadratic equation, and that's that y equals ax squared. I would like you to make sure your notes are out right now, and the whole point of this is that by using this graph you will be able to describe certain parts of it, you'll be able to graph it. So let's get started. Alright guys, go ahead and title this in your notes, graphing y equals ax squared. By the end of this, you will be able to tell me the characteristics of the graph, and I will go into detail what the characteristics are. You will be able to tell me what this letter a, this variable a in front of x squared, does to the shape of the graph. So let's go ahead and start off by talking about what are the characteristics that I need you to be able to identify in a quadratic. The first one, the one that we've talked about a lot, is the vertex. The vertex is the point at which it changes direction. It could be the lowest like it was in this example, or it could be the highest like it will be in another example. Alright, I've been talking about how quadratics have this symmetry. The point at which the vertex is, that vertical, you see that little dash on the graph? That vertical dash is that axis of symmetry. So if we were to fold, if this is on a piece of paper and we were folding the paper on this dashed, the two red and blue lines would overlap, and that's how it has symmetry. Alright, let's review. So there's 2 points of characteristics that we just talked about, called the vertex and the axis of symmetry. I'm going to pause there on the characteristics, and we're going to go ahead and start describing what this a does to the shape and come back to characteristics again. So a, when a is 1, this is your normal y equals ax squared shape. This is your normal parabola shape. When a, this factor of a, when you multiply by a, what it does to your parabola shape is it makes it skinny. Okay, now let's think about it. What if a was less than 1? Or more importantly for this one, since the U shape is going up, it'd have to be in between 0 and 1. It makes it fat. Alright, what if a was less than 0? Let's go ahead and look and see what happens when a is negative numbers. When a is negative, they all flip over and are like frowning now. The normal shape, when a is negative 1, is this blue line here. This is your normal. Okay, it's like your go-to, most easiest parabola shape when it's negative. When a is less than negative 1, just like it did with your positive a's, it makes it skinny. And when a is in between negative 1 and 0, when it's a decimal, it makes it fat. Alright, now we're ready to go back into the characteristics. So, example 1, we are looking at identifying the characteristics we just talked about, and I'm going to put over here, and so should you, in your notes on this left-hand side, what are all the characteristics you need to list out. The first one is that vertex. Your vertex for example 1 is right here, so our vertex is 2, 8. Alright, the second thing when I ask for characteristics is that axis of symmetry. I'm sorry, I'm going to abbreviate it. I'm running out of room. The axis of symmetry for this parabola on example 1 is where I'm putting this dot, this dashed line. It's where the vertex is. And we can just call this as x equals 2. Because if we fold it on the x equals 2 line, the 2 halves of the parabola would line up exactly. So this is your axis of symmetry. Alright, then third thing, that's a super important characteristic, and we've talked about so many times, is your y-intercept. That means we're also going to have to talk about your x-intercept, or x-intercepts, because there could be more than one, there could be none, so your x-intercepts, and we're going to add on now, we've talked about this a lot, we're going to talk about domain and range. Those are all the 6 important characteristics. You can tell your reader so much if you list all of these 6 things. So let's go ahead and finish listing out all of this. So we have our axis of symmetry. Our y-intercept is at y equals 4. Remember, you can write it as y equals 4, or you can write it as 0, 4. Both are okay. Your x-intercepts, I'm going to go through and I'm going to approximate where my x-intercepts are. So the x-intercepts are at x is approximately -1 and x is approximately 5. There's 2 for this one. All right, let's go ahead and talk about the domain. If we were to take our line and smash it on this x-axis, will we hit all the numbers forever? Remember, this continues going, getting bigger and bigger and bigger. The answer you should be thinking right now is yes. So the domain is x is all real numbers. Okay, let's go ahead and talk about that range. If we were to take this parabola and squish it on the y-axis, we would not hit all real numbers. We would be hitting y is less than or equal to 8. And you did it. These are all the very important things when you're telling your reader what the important characteristics are. I like to include this point before and point after when you're graphing. Those are helpful when finding the pattern. So we just talked about the characteristics of quadratic equations. Now let's go through and compare how you can see what's happening from a quadratic to another quadratic. The difference between these two is this one is your simple one, and what happens is something is happening when we multiply it by a half. Let's figure out what's happening when we multiply it by a half. So I'm going to start off by making a graph and making a table so I can keep track of my points that are going to go in my table. So this one is going to be the table for x squared. So if I plug in 0, 0 squared is 0. If I plug in 1, 1 squared is 1. If I plug in 2, 2 squared is 4. If I plug in 3, 3 squared is 9. All right, I have enough information to at least get half of the one side of my graph. So let's go ahead and do that for that x squared. 0, 0, 1, 1, 2, 4, 3, 9. I'm just sketching it. This isn't exact, but if you're using your graph paper, yours is going to look much nicer. Let's see what happens when we look at the 1/2 x squared. Half of all the x squareds is what it's saying. Take half of x squared. Okay, 0 squared is 0. 0 times a half is 0. So they start at the same points. They both start at the origin. 1 squared is 1. 1 times a half is 0.5, a half. 2 squared is 4, and 4 times a half is 2. Ooh, what happens? Starting to see a difference a little bit more. 3 squared is 9, and half of 9 is 4.5. So let me go ahead and graph it so we can kind of see what's happening. So we have 1.5. We have 2 and 2. We have 3 and we have 4.5. What happened? Did our shape get skinnier? Did it stay the same? Did it move to the right or to the left, up or down, or did it get fatter? This one, when you're comparing the two graphs, you're going to tell me that it got bigger. Well, it got fatter, got wider. The stretch factor makes the graph wider. Wider. All right, let's go look at this with another example. Example 3, we're looking at what's the difference between these two equations. That this one has a stretch factor of a -1/8. So let's make our graph, and a couple of tables so we can follow along with our ordered pairs. Our first one, x squared, I'm just going to remember what we put down from that last one because it was the same one. 0, 0, 1, 1, 2, 4, 3, 9, 0, 0, 1, 1, 2, 4, 3, 9. This is the same example as our last one. Okay, there's our 1/2 of our shape. Okay, let's go ahead and make the table for taking a -1/8 of x squared. So if we plug in 0, 0 squared is 0, times -1/8 is 0. So they're starting off at the same place. 1 squared is 1, times -1/8 is -1/8. 2 squared is 4. 4 times -1/8, let me put some scratch work. 4 times -1/8 is the same thing as -4 divided by 8, which reduces down to -1/2. So now it's a half, -1/2. Okay, one more point, 3. 3 squared is 9. So now we're going to do 9 times -1/8. This would be equal to -9/8, which reduces down to -1 1/8. -1 1/8. So what happens when we compare this black line to this blue line? So it flips, obviously. And does it get narrower or does it get wider is the next question. Then 2 would be 1/2. And 3 would be 1 1/8. Does it get narrower or wider? You see how my points are all kind of close to each other? That tells me it's getting wider. So flips and wider. Okay, that's how you compare them. For the next 1, 2, 3, 4, 5 problems, you go ahead and try them. When you're ready to talk about what happens, go ahead and press play, and I'll go over it. All right, number 1. When you identify the characteristics of this graph, you should have told me that the vertex was at -3, -4. You should have told me that your axis of symmetry was at x equals -3. You should have told me that the x-intercepts are at -1 and -5. You should have told me that the y-intercept is at 4-ish, approximately 4. Then you should have told me that the domain was all real numbers. And the range was y is greater than or equal to -4. All right, when you're looking at comparing these four, number 2 compared to x squared got skinnier, stayed the same smiley face, but got skinnier. 1/8 made it get wider. -4 made it flip side, so it's a frowny face, and it got skinnier. And -3/5 made it flip, so it's this frowny face, and made it got wider as well. All right, go ahead and answer your essential question and go take that checkpoint. I hope you guys have a great night. See you tomorrow.